When a software house begins developing a system for a stakeholder, between the stakeholder's vision and the analyst's interpretation lies a gap. A gap that, if left unchecked, can derail even the most promising project. On one side, the stakeholder, perhaps a business owner, a departmental head, or a client with a clear need. They know what they want, or at least they think they do. On the other side, the software analyst, tasked with translating that need into technical requirements, workflows, and deliverables. When a software house starts to develop a system for a stakeholder, they begin with the shared goal, but the gap in understanding threatens success. This video explores how to bridge that gap in understanding. The first problem is that the stakeholders and the analysts effectively speak different languages. The stakeholders tend to focus on goals, outcomes, and frustrations with the system that they've currently got. Analysts think in systems via data models and concepts. They have a different mindset. This misalignment is because of different perspectives. A stakeholder might say, I want a dashboard that shows sale performance. But what does that really mean? Real-time data? Historical trends? Drill-down capabilities? The analyst needs precision, and without it, assumptions will creep in. Vague requests from a stakeholder lead to unclear requirements. Analysts can fill gaps with assumptions. They shouldn't. Assumptions are the silent saboteurs of software development. They creep in unnoticed, tiny, quiet, and corrosive, gnawing away at clarity and collaboration. The result of assumptions is that features nobody uses are produced and deadlines can be missed. Another undesirable effect of assumptions is assumptions are expensive. Of course, you may be asking, well, how can an assumption be expensive? Well, if the analyst has made an assumption, that assumption will become part of the requirements analysis document. This documentation is then passed on to the design phase, where the designers will alter the design documentation to reflect the requirement, which in fact is not an actual requirement, it is an assumption that's been made by the analyst. Of course, when the designers have finished changing their design documents to reflect this assumption, they pass it on to the coders, onto the implementation phase. The programmers then write the code as specified by the design documentation, some of which is not needed because it certainly wasn't asked for by the stakeholders. It's the assumption that was made at the beginning by the analyst, which they shouldn't have done. And when this unnecessary code has been finished, it moves on to the testing phase. So it is tested to see if it works as expected, when in fact nobody wanted it. So the assumption made by the analyst, and let's be fair here, we're assuming it is an incorrect assumption, has rippled through the software lifecycle. And of course, all of the activities that took place in implementing this incorrect assumption cost time and money, because you had to pay the programmers, you had to pay the designers, when they could have been working on something else. So it can actually slow down the development of the software, and any deadlines can be missed. The role of the analyst is to find out what the system should do. That's what they have got to discover. They concentrate solely on what the stakeholder, what the customer want the software to do when it's finished. To discover what the proposed system should do when complete, analysts ask questions, lots of them. They don't assume, they investigate. Typically, analysts often watch how tasks are done. This helps them spot inefficiencies and uncover hidden needs. In other words, they observe the stakeholders carrying out the tasks of the business to glean a better understanding, to inform their inquiries so they can find out what the system should do when it's finished. This is part of the investigation. An analyst really shouldn't be involved in how the system is put together, how the design documents move forward, how the coders code these design documents. Their concentration should be on finding out what the proposed system should do. That's the purpose of the requirements analysis phase. What the system should do, not how it should be done. That's up to the designers and the coders. The main task of analysis is this notion of what. What should the system do, the proposed system do, when finished? And the documentation they produce guides the entire software lifecycle because it's continually referred to throughout the other lifecycle phases. We need to know how to bridge the gap, and it starts with empathy. Now, what this means is analysts must explore the stakeholders' world. An analyst must get to understand what the stakeholder wants and how their business needs are met by the proposed software system. This is made easier if the stakeholders welcome clarification. Now, what this means is the analyst will ask lots of questions of the stakeholder. If the stakeholder starts getting frustrated with the questions being asked because they want to get on with their daily role, there can be a problem arising because of a lack of appropriate communication. So an analyst must be good at asking questions and must have empathy towards the stakeholder to glean as much about what they want the system to do when it's finished as possible without effectively upsetting them and getting on their nerves. So empathy is essential. Good interpersonal skills are the requirements for good analysts. Mock-ups as to how the software will look help with the communication between the stakeholder and analyst. And there is also something referred to as use cases, where you have use case diagrams, which can also assist with the communication between the stakeholder and the analyst. And this is something I'll be looking at later in the playlist. Continuous collaboration between the analyst and the stakeholder is the key to a good requirements analysis phase. Regular feedback loops between the analyst and the stakeholder will prevent assumptions and will also bridge the gap in understanding between the analyst and the stakeholder. Shared ownership of the software development improves outcomes. In other words, if the stakeholders and the analysts work together and both can see the project moving forward, then you're likely to get much better requirements during the requirements analysis phase. Living documentation, as you would expect to see during the agile model of software development, keeps everyone aligned. In other words, you keep on seeing the analysis, the design documents being updated, and the analysis document can be used to further communication, good communication between the stakeholder and the analyst. We have to go from a gap in understanding to mutual success when we're developing software for a stakeholder. Good software is sculpted through dialogue, and nowhere is that dialogue more important than when you're doing the requirements analysis of the software lifecycle. Also important is empathy, clarity, and collaboration. They all drive toward good results from the requirements analysis phase. The gap is real, but it is bridgeable. An analyst has got to discover the what of the system. Let's just focus in on this a little. Let's say that the stakeholder says, I want to track customer orders. The analyst has to dig deeper. The analyst will ask more questions, such as, what data needs to be stored to meet this requirement? Who updates the data? What reports are needed? What do you want the reports to look like? And so on. Continuing with the what of the system, mock-ups and use cases help turn vague ideas into concrete requirements. A mock-up would typically, in the early stages of the requirements analysis, show what the software is likely to look like. Of course, if you use the agile model, you'll be able to keep on showing the stakeholders some working software as it develops throughout the time that you're producing the software system. Use cases and the diagrams that support use cases are an excellent way of allowing effective communication between the stakeholders and the analysts, and we'll be looking at use cases later in this playlist. The move into concrete requirements is to make sure everyone agrees on what the system should do. Reducing the gap in understanding between the stakeholders and the analysts moves towards everybody agreeing on what the system should do. An extremely useful approach to reducing this gap in understanding and moving towards the what of the system is achieved by the use of use case diagrams and use cases. And these are particularly useful if you're going to be developing your software in the object-oriented paradigm, because use case diagrams and use cases support concept-driven analysis as opposed to data flow analysis. Put crudely and somewhat simply, identifying concepts during the requirements analysis phase will allow, when you move into the object-oriented development of software, the identification of possible classes where there could be a one-to-one relationship between the concept that you've identified and the class in the object-oriented programming language. Continuing with the what of the system. The what isn't discovered all at once. Analysts will share drafts of what they found with the stakeholders. They will get feedback from these stakeholders. And of course, if you use the agile approach to software development, this is baked into the approach because you keep on going back to the stakeholders and showing them some software that's been developed based on the requirements that they've already given you. Or more accurately, what the analysts have found out from their investigations, which of course relies on intensive communication with the stakeholders. The focus of reducing the gap in understanding is in the service of finding the what of the system. It's to make the system's purpose crystal clear. So I would like to conclude with the following. Bridging the gap in understanding is all about finding the what of the system.